Time travel. Introduction. The concept of time travel has become a persistent echo in my mind, a thought I simply can't shake, even when my attention is focused elsewhere. This fascination led me to ask friends and colleagues about their own understanding of it. Interestingly, while their individual interpretations varied slightly, a common thread emerged: a belief in its potential for immense personal gain, the ability to change fortunes and outcomes. This collective vision, however, sparks a deeper question within my own consciousness. Is such a thing truly possible? And more importantly, would time travel genuinely hold the transformative power we imagine? Possibility to travel to past? In the quantum realm, the nature of time becomes far more abstract and is still a subject of intense research. Many of the fundamental laws at this level are time symmetric, suggesting a different relationship with time than we experience macroscopically. While some theoretical frameworks explore exotic possibilities, the idea of particles simply moving forward and backward in a straightforward manner, or macroscopic time travel occurring at the quantum level, is not a well-established or easily understood phenomenon. In contrast, in our physical world, time relentlessly marches forward at a constant pace of 1 second per second, never in reverse. It seems as though time is vibrant and active in its progression towards the future, while the past remains a static, unrecoverable domain. Just as a body, once deceased, releases its atoms back into the natural world in a process that cannot be undone, so too does time appear to flow in a single, irreversible direction. Therefore, our natural state allows us to move only forward, into the realm of the living. Indeed, time's very essence is intertwined with change. If change was still occurring in what we perceive as the past, it wouldn't truly be the past. It would still be an active part of the ever-evolving present. Moreover, past traveling creates paradox and loops logically. Possibility to travel to future. While the allure of revisiting the past to change fortunes might be a common fantasy, the theoretical obstacles seem immense. However, let's shift our focus to the seemingly less paradoxical idea of traveling into the future. Therefore, if travel forward were possible, it logically follows that the future, like a destination already existing, should be predetermined. Consider a train journey from station A to station B. If the train is already running from A towards B, then station B must also exist. We simply haven't reached it yet. Time travel forward in this sense is akin to fast forwarding our time sense to arrive at station B. But if the future is a pre-existing destination, what purpose does altering it serve? Hypothetically, if we did manage to change something, it would likely create a new, separate timeline, leaving the original future untouched. If we were to continuously alter events, we would generate an endless series of new timelines, making it impossible to discern the original from the copies. This constant branching, and the inability to truly change our own past, could be a more unsettling prospect than even death. Time dilation, a real form of time travel. Time dilation is a phenomenon in physics, specifically in Einstein's theory of relativity, where time passes at different rates for observers who are in relative motion or who are in different gravitational fields. In simpler terms, two observers moving at different speeds relative to each other will measure different time intervals between the same events. Similarly, two observers located at different distances from a gravitational mass will also experience time passing at different rates. Time dilation represents a real, subtle form of time travel that has been experimentally verified. Consider this hypothetical analogy: identical twin brothers, A and B, both aged 20. A invents a vessel capable of traveling at near the speed of light. They decide to conduct an experiment. A will be inside the vessel, and B will remain on Earth. Both have synchronized watches. When the vessel accelerates and reaches near light speed, it continues its journey. From A's perspective inside the vessel, his watch runs normally, and he feels no unusual changes. Similarly, from B's perspective on Earth, his watch also runs normally, and he feels no changes in his own passage of time. However, A would observe that time on Earth, and therefore B's aging, was proceeding at a slower rate than his own. Conversely, from B's viewpoint, A is moving incredibly fast. When the vessel eventually returns and stops, A emerges to find that B has aged significantly more than he has. In this scenario, time has passed more slowly for A relative to B. For example, if the journey lasted what felt like 5 years for A, B might have aged 50 years. This demonstrates that time flowed differently for them. Even if we consider their lifespan fixed at 60 years, if this journey caused a 5-year difference in aging, B would potentially die 5 years earlier in Earth's time than A. While time dilation offers a genuine form of travel into the future, the amount of time gained is minimal at everyday speeds and requires extreme velocities to be significant. This raises the question of its practical utility for human endeavors. Now consider another hypothetical scenario. A couple, A and C, board a vessel traveling at near light speed. While in transit, they experience time normally and conceive and give birth to a baby, D. Immediately after the baby is born, the vessel stops and returns to Earth. What would be the age of baby D upon arrival? The key here is that time dilation affects everyone and everything within the moving frame of reference equally. From the moment of conception until the vessel stops, time passes normally for A, C and baby D inside the spacecraft. Therefore, the age of baby D when the vessel stops and returns would be however old the baby was at the moment of birth, plus the duration of any travel time after the birth, as experienced by A, C and D within the vessel. For example, if the journey after the baby's birth lasted for what felt like 1 week inside the vessel, then baby D would be 1 week old upon arrival. The time dilation experienced by the vessel would mean that significantly more time might have passed on Earth during that week. But the baby's age is determined by the time elapsed in its own frame of reference. Conclusion. Considering the theoretical impossibilities of past travel, the potential for a predetermined future, and the limited extent of time dilation, we return to the fundamental question: what is the true use of time travel? Even if we were to travel through time, the constraints of causality and the potential for branching realities suggest that our ability to alter the past or even significantly impact the future in our original timeline might be severely limited. Perhaps the true fascination lies not in the power to change time, but in the profound understanding of its nature that these thought experiments and scientific inquiries offer. By grappling with these concepts, we gain a deeper appreciation for the linear flow of our own experience, the delicate balance of cause and effect, and the very fabric of the universe we inhabit. The enduring allure of time travel, therefore, may not be about escaping our present, but about illuminating the fundamental mysteries of time itself.